Good afternoon, everyone.
Good afternoon, Doctor.
Okay, thank you, Enric. Let's continue with our class, our lesson. I probably will just show one. Will just do one exercise today. Um, so our class most probably will not extend. Will not be beyond 1 hour. Because I just want to go slow on this topic, which is flow over broad-crested weir. Um, Now let's look at this the activity that we are supposed to do that I said I would go through with you, and then I've already assigned who's going to do the next activity for our next class. Right, so let's look at activity 3.11 first. So I'm going to share the whole screen. Um, okay, you should be able to look see my screen already, right?
Yes.
Okay, thank you. Thank you for the response. Now let's look at this activity. It's actually very simple. I last class, right, we have looked at so many formula, right, and there are so many cases. Well, not many, there are only 3 cases, but then it also depends on whether the upstream condition is subcritical or supercritical. Now let's look at this activity 3.11. I'll actually, I didn't memorize all the formula for this topic, but I kind of, when I draw the EY curve, the specific energy curve, I can actually get the formula from there. However, all right, in your final exam, we will provide you with the table of formula that the one that you have seen in your test. All right. Okay, now let's try this out. Activity 3.11. The question say rectangular channel. So once it's a rectangular channel, you know that you can use the simple formula of to find E mean, to find YC, which is the depth of critical flow, and you also can use discharge over unit width, which is the lowercase q. Now let's try this out. All right, I have a rectangular channel. Okay. Now the depth of flow. All right. So the depth of uniform flow is given already, so you don't need to find it in this exercise here. All right. Okay. Now this is equal to 1.6 meter. And then the hydraulic radius, okay, is also given, which is 0.77 meter. By now, you should know what is hydraulic radius already. By right, if it's not given, you need to find flow area as well as depth, hydraulic radius. Then R is equal to A over P lah. Okay. All right. Now, and then the longitudinal slope is given as 1 over 3,000. All right, that is like 0.0003333. All right, And then Manning roughness coefficient is 0.01. Okay, you can, use through this Manning roughness coefficient, you actually can guess what type of channel lining it is. Now, the first question is, what is the minimum height of weir to control the flow in the channel? Our first few slides in chapter 3, we learn about control sections. I've told, through that control section class, lesson, we have learned that typically at the control section, the critical condition occur. Okay, so now the question asks, what is the minimum height of weir? That means to control. That means is when there's occurrence of critical flow. So this is actually the question where it asks you to find the minimum height of weir, which is H min, and when H equals to H min, it is also case 2. All right. Now let's look at here. Let's assume I don't remember the formula. Of course, it'll be provided to you too. All right. So the next thing that I want to do would be, I'll just draw the EY curve. I have the specific energy curve. All right. This is the E equals to Y line. So I have the specific curve. All right. Which is going to asymptote lah, all right, on this line, and also the x-axis here. I know that, given y naught equals to 1.6 meter, there's a initial specific energy, which is denoted by E naught. Then, at this point here is when the specific energy is the least, which is the E min, right? The minimum specific energy. And corresponding to E min, I have a critical depth of flow, YC, and also corresponding to E naught, I have Y naught. Now, here I don't know whether this Y naught equals to 1.6 meter is in subcritical or supercritical flow. If it is in supercritical flow, the point is here. If the depth is in subcritical, the point is here. This is the depth, right? Now, what are we going to do is, of course, we want to establish whether the depth of flow is sub or supercritical, all right? Now, YC is not provided, all right? Typically, okay, if you want to find H min, right? Now, I hope you still remember, E min plus H min, you'll get E naught, because we in case 1 and case 2, well, typically if there's no energy loss and the energy is conserved, all right, the total of specific energy or total of energy remain the same. Okay, so E min plus H, if you can draw the diagram, if you still can remember, right? Okay, this is H. All right. So I don't know what case it is. I'll just draw a supercritical condition. So I have E, all right, total E. This is specific energy. So E min, if this is a critical condition at 0.2, all right, this is 3, sorry. Then this is H min. So H min plus E min, I'll get E naught. All right. Okay. Now, so this is, this distance here is actually H min. So this is how I don't have to, this is how I get the equation. I don't have to memorize it lah. Basically, H min is E naught minus E min. So now you want to find H min. You need to find E min and E naught. E naught, you can get it from Y naught. Once you know Y naught and Q, you can find E naught already. However, for E min, you also need to know YC. Here's the thing, we don't know YC. So this is where we need to find YC. Now, for rectangular section, all right, you can use the formula of Q squared over 2G to the power of 1/3. However, we still need the discharge over unit width. So what we are going to do is we need to find the discharge first. Okay. So now, okay, let me show you the initial equation, the Manning flow resistance equation is 1 over n, sorry, A r to the power of 2/3 S naught to the power of half. Now, dividing both sides with B, because this is a rectangular section, I can actually use discharge over unit width. So dividing B on both sides, okay, I would get, okay, let's just show this, all right? That means this is divided by B. It doesn't matter, I just put 1 over B, all right, on the right side. So I can reduce this to 1 over n. This is actually for rectangular section, you have B times Y, right? B times Y naught lah, because this is Manning formula. I have Y naught R to the power of 2/3 S naught to the power of half. This is how I reduce it. Now, if, you know, if you don't have, if hydraulic radius is not given, you need to find A and P, okay, in order to get R, in order to, substitute in this equation. Now R is provided, so I don't need to find it already. So what I have here, I can substitute all the known values, right? I need to find my discharge over unit width. So I have 1 over 0.01. Can someone help me calculate this, please? And this is 1 over 3,000 to the power of half. Okay, so Q is anyone can help me give the discharge?
Okay, calculating, madam.
Sorry?
Calculating.
It's 2.454, right?
Yes.
Right, thank you. So this is to the 4 significant number, Okay, I wrote this, my answer is written, okay, in 4 significant number. So I have discharge is 2.454 meter cube over second over meter. Now, once I have this, I can already find my YC. If you still remember our step, right, we normally find Y naught and YC. Okay, this is our first step. So YC would be, now, if if it's not a rectangular section, of course you need to use this equation, right? Okay, this equation. But now I can actually simplify it because I have rectangular section, right? I can simplify this. I'm using this equation here. So that is why I need to find my discharge over unit width. Okay, so what is my depth of critical flow, please?
Zero point 0.8499.
All right, great. Thank you. So it's 0.8499 meter. I hope everyone try this out, because I'm going very slow. I don't know. Definitely there will be a question on, this chapter. I don't know because there are only two problems, which is flow over broad-crested weir and flow through constricted channel. So you need to know. This is very simple actually, the problem, okay? If you have problem understanding, please do, do contact me, all right? So after I get YC, okay, I can actually find my E naught, okay, based on Y naught, and E min based on YC, in order to get my H min. So E naught is can you help me find E naught?
1.719.
I actually get 1.720.
Are
But
you?
similar, yeah, I think
Yeah,
our
sure.
answer are similar, right? Because I kind of, okay, wrote it in four significant numbers. Okay, now here's the thing. After I have E naught, the next step would be I need to find my E min, the minimum specific energy. So it's 3 over 2 YC. So it's 1.5 times YC is 0.8499. This will give me
1.275.
all right, thank you. Okay. So therefore H min is our H min.
0.445.
Okay, thank you. So it's 0.445. Okay. Now, okay, we have already answered the first part of the question, minimum height. Okay, that is done. Okay. Second part of the question, okay, ask us calculate the depth. That means we need to determine the depth of flow upstream, downstream, and above the weir in A. Question A is actually when H equals to H min, which is our case 2, right? So in case 2, okay, if you still remember, let me put it down first. H equals to H min equals to 0.445 meter. This is our case 2. Sorry, I should put when H equals to H min, right? This is case 2. Then, okay, for case 2, okay, who can remember what is our Y1, what is our Y3, and what is our Y2? For case 2, Y1 equals to Y3 equals to Y naught. And in this case, our Y naught is 1.6 meter. All right. Now, for case 2 also, Y2 equals to YC. Remember, for when, now, remember the definition of H min is the minimum height of weir that will cause critical flow to occur above it. So therefore, for case 2 and case 3, Y2 is equal to YC. Okay. Therefore, Y2 equal, this is case 2. Yes?
Y hash equal to hash min.
I'm sorry?
Why the y hash equal to hash min?
Because the question say calculate depth of flow and the depth of flow lah, upstream, downstream, and above the weir in A. For case A is the height of weir when it is minimum height, right? Am I right?
Yes.
So am I right to say it is case 2 because the H equals to H min?
Yes.
Correct. Okay, so therefore it is case 2. So therefore, YC would be 0.8499 meter. You know, you can check your answer. Well, just roughly, E min should be less than E naught because it's the minimum specific energy. All right. is the least specific energy, so it won't be greater than E naught. Okay, that is one. What else? Okay, later I'll tell you some other tips. All right. Okay then. So that's it. You have solved for B. Now, if I go back to my specific energy curve, right? Okay, look at here. Well, you also can check whether this is subcritical or supercritical. You see my YC is 0.8499 meter. Now, my Y naught is actually greater than my YC, which should be this point. Therefore, my Y naught is in subcritical state. This is my Y naught, which is equal to 1.6 meter. All right. Of course, you can write down whatever value if you want to write, which is the A mean and E naught. All right. So, therefore, to know how to draw this is important. Okay. It actually help you um, understand the formula as well basically. All right. Now, let's go back, okay, to part C. All right. Part C asks us to calculate the depth of a. Basically, you need to find Y1, Y2, and Y3 when, okay, there are two cases. The first case is, okay, C1 would be when H is equal to 0.4 meter. Now, in this case, okay, we have established our H mean to be 0.445 meter. So when our H is 0.4 meter, which is less than H mean, okay, may I know, okay, maybe I'll call Kampao. Kampao, which case is this? Kampao? Are you there? You're not there? How about Piria? Is Piria there? How come no one is there?
Doctor,
Yes.
is
Ahmad
it
Aizat.
case 1?
Yes?
Is it case 1?
Yes,
Case
correct.
1?
Why Aizat?
Sebab
Why case 1?
because the H mean is larger than H.
Great, thank you. Is
Okay.
H because H mean larger than H or H is less than H mean, right? Okay, so
Yes.
therefore this is less than H mean. Therefore, this is case 1. Thank you, Aizat. Okay. Now, okay, case 1. Now, for case 1, if you still remember, we have already established that y1 equals to y3 equals to y naught equals to 1.6 meter. So, we have solved y1 and y3 already because y1 is equal to 1.6 meter and y3 equals to 1.6 meter as well. So, the next thing that we need to find is y2. Aizat, may I know is y2 equals to yc for case 1?
Case 1, Y2 is not equal to YC.
Okay, it's not equal because it's less than h mean, right?
Yes.
Okay, great. Thank you. So we need to find y2. Now, how are we going to find y2? So what I'm going to do now is I'm not going to ask you to memorize the formula or look at the formula. I'll just draw the EY curve. We can actually get the formula from the EY curve, all right? Now, for case 2, okay, our H is, this distance here is H min, but our H is less than H min, so okay, I don't know where is my E2. We need to find out. So this is the distance of our H, because this is our E2 here. I'll just point this out. E2. Okay, E2 is slightly greater than E min. I don't know by how much, but when E2 plus H, you'll get back E naught. So the formula here, here's the thing. How are we going to get E2 is your E naught minus H. You are going to get E2. That's simple. So that's why I told you when you draw this, either you draw the diagram of flow over weir, you can also get it, or you just, draw the EY curve here. So therefore, okay, what I'm going to do now is, now another thing, just now we have already established our Y not to be subcritical. Okay, let me draw this flow here. Okay, now our Y2, you see there's no changes, this is not critical flow. It's all, the flow is still in subcritical condition. So our Y2 should be in subcritical state as well, not this one here. Since later we need to solve our equation in using calculator, that means through the concept of trial and error, you'll get two solutions, but the right one is this one, because the initial condition is in subcritical state. So therefore, our Y2 is in subcritical state as well. Now, here's the thing. We need to find Y2. How do we need to find Y2? We need to know E2. So therefore, E2 is E naught minus H. Our E naught is 1.720 minus H 0.4. Therefore, E2 is 1.320 meter. Okay. Now, the same specific energy equation, you have E2 equals to Y2 plus Q squared over 2GY2 squared. Okay, so I'm going to rewrite this, okay, because I want to solve for Y2, right? So I have, what is my discharge? 2.454 squared. Y2 squared equals to 1.320. Okay. Therefore, solving this, I'm going to get 0.3069. Okay, help me check. You guys help me check whether this is correct or not. That means I'm actually solving 2.454 squared divided by 2 divided by 9.81. So I have, okay. Now, can you help me find Y2? I want to find this depth here, all right, using this equation. Could you please try it out, this one? Anyone got the answer already?
I don't know. I got 0.7083.
0.7. Okay. Now you should get, okay. Tava, I'm not sure. You probably have to check. Now, if you get 0.6 something, right? Teva, you actually try to substitute back in this equation. That means 0.6 something plus 0.3069 divided by 0.6 something square. It should be equal to 1.32. If it's not equal, that means there's something wrong. Well, you should get two answer, all right? But only one answer is the correct one. Remember, don't give me both answer, because I only want to accept one. I mean, like if you give me two, still I think you don't understand. Okay, the question. So I don't know whether you can get this or not. 7085 meter. You should get this.
I got 0.7084.
This is not correct, because the one that you get is here, supercritical one, which is less than YC. Remember, I just now, that's why I tried to explain that you should get another value which is in subcritical state.
So how we should get the 1.032?
I believe remember our last class, somebody informed that you can actually key in this, or you can actually solve this
Equation
equation
method, is
here,
it?
using calculator, right? But I
Yeah.
think you need to times, you are going to get y2 cubic power plus 0.309 equals to 1.32 y squared.
Okay.
You need to write it down like that, then you can solve for it lah. I'm going to share I remember sharing the YouTube already in our WhatsApp group. How to solve this? Just now is you, right, Priya?
Yes, I did.
Okay. Try. Okay. Because I think last exercise, right, a few exercise that we have done, we also need to solve for this too. All right. So I think by now you should know lah, all right, how to get two answer. Because remember I told you, right, this is the alternate depth. That means if provided it is not E mean, for other specific energy there are two depths. Okay. So in this case I only accept one depth, which is this one here. Okay. You can check. You can substitute this value into this expression. You'll get 1.32. Okay, this one as well. But this is not acceptable because this is supercritical depth. All right. So, okay, so far so good, everyone?
Not really.
Okay. Who is that? Where is the problem? Okay, let me know. Enric, yes?
Because just now I used a calculator to solve the equation, and I got 0.7 as well.
Okay. Who have tried? Who can get both answer? 1.032 and 0.7085 meter. Okay, don't worry, Enric. I'm going to share the YouTube video again. You try it out. So this would be everyone's activity later, because I guess I'm going to spend another 15 minutes with you. Then I'm going to share the YouTube, and I'll it's a asynchronous delivery lah, where I can I'll teach you how to solve it using calculator. Okay, Mafira. Can I help you, Mafira?
Saya dapat.
Dapat dua-dua jawapan
Doctor,
guna calculator ke, Mafira?
I think we need to do the equation, right?
Yes, you need to
ABC.
rewrite this. Here's the thing. Like this is question, right? Mafira, boleh ajarkan tak?
Okey, kan Y2 tambah
Jadi
0.069 per yang bawah tu, yang Y2 tu darab ke Y2 yang situ, yang tepi yang kiri tu. Lepas tu lepas tu yang Y2 yang bawah tu darab pula dengan 1.320 tu. Lepas tu
macam ni
nanti,
kan? Betul, macam ni kan?
sekejap. Betul?
Okay, so jadi saya tulis balik, saya susunlah ikut kuasa sorry, ini akan jadi negatif betul Jadi saya akan dapat persamaan ini kan? Betul Mafira? Okay, lepas tu?
Tekan kalkulator. Ambil
Okay,
mode.
Mafira nak share tak? Mafira ada video tak yang boleh tunjukkan kalkulator?
Tak, saya buat manual je.
Buat manual. Lepas tu? Okay.
Tekan kalkulator, ambil mode, jumpa EQM. Lepas tu ambil degree. Lepas ambil degree tu tekan yang 3 tu.
Teruskan? Dapat.
And degree 3. Lepas tu yang A tu masukkanlah nilai 1. Lepas tu yang B tu nilai negatif 0.1320. Lepas tu C tu kosong, D tu 0.3069. Lepas tu dapat.
Okay, thank you. Thank you Mafira. Jadi nanti sebenarnya video Mafira cara Mafira selesaikan tu sama kan dengan cara YouTube video yang saya pernah share, betul tak Mafira?
Yang video tu dia pakai kalkulator yang high advance kot.
Oh ya, yang advance, okay. So Mafira bukan advance okay. Kalau gitu, boleh tak Mafira ajar kita macam mana nak guna kalkulator Mafira next class? Bukan secara lisan tapi secara tekan kalkulator. Boleh tak Mafira? Mafira?
Ya.
Video Mafira tu tunjuk pada kalkulator Mafira untuk tekan. Boleh ke?
Boleh kot.
Boleh kot. Okay, tak apa. Saya minta Mafira tunjukkan Rabu depan boleh? Supaya Mafira ada masa. Ahad, sorry. Hari ni Rabu kan? Ahad depan. Boleh Mafira?
Boleh kot.
Boleh kot. Jangan kata kot-kot Boleh lah Okay. Jadi, next class, the first thing that I'm going to, first session would be Mafira session for next class. Meanwhile, I'm also going to share the YouTube again. Okay. I guess the concept should be the same lah how to solve this. Alright. Okay. This is yes?
Yang ni untuk dapat yang tengah buat ni untuk dapatkan 1.032
Ya, sebenarnya untuk dapatkan dua-dua Aizat 1.032 dan 0.7085. Aizat dapat tak?
Dapat 1.032.
Tapi jawapan satu lagi dapat tak? 0.7085.
Tak dapat.
Sebab kenapa? Kita kena dapatkan dua-dua jawapan sekiranya keadaan aliran asal ialah supercritical, maknanya patutnya jawapan dia bersamaan 0.7085. Sebab dalam soalan kita kali ini keadaan aliran asal adalah subcritical. Jadi Y2 kita ialah 1.032 meter. Kebetulan lah Aizat dapat kan? Tapi ramai yang dapat 0.7085. Sepatutnya kita kena dapat dua-dua jawapan. Boleh? Jadi kalau gitu, don't worry. Okay, once you know how to get this, you can actually solve this already. Okay, now this is question C1, where when H equals to 0.4, okay, you already have, you already showed that your Y1, since H is less than H mean, it is case 1. y1 equals to 1.6, y3 equals to 1.6 meter, and your y2 is, this is the correct one, because I already explained that since your y0 is in subcritical, it should, it should be reduced, the depth should be reduced, but it didn't change state of flow. It's still in the same as initial, which is in subcritical state of flow. So your y2 is 1.032 meter. Okay, now this we have already solved C1. Now for C2, all right, the second part of the question is when H, so if H equals to 0.6 meter, okay, therefore this is greater than H mean, which is 0.445 meter. This is our case 3. Okay, oops, okay, now for case 3, the one that I know, all right, is y2 is equal to yc equals to 0.8499 meter. So I don't need to solve for y2 already. I need to solve for y1 and y3. Now remember, regardless of the initial condition, whether it's subcritical or supercritical state of flow, when it is case 3, y1 would be in subcritical state and y3 is in supercritical state. If you still remember, right? This is the case when H greater than H mean, alright? So your y3 is less than yc. Your y1 is greater than yc lah. Okay, basically, alright? Now, how are we going to find y1 and y3? I'm going to put a prime here because you need extra energy, all right? You need additional specific energy to find it. Now, let's look at our EY curve, all right? Okay, now, since our H is greater than H mean, how do I find my y1 and y3? So therefore, all right, starting from my E mean, I have my H. So I'm going to have a new specific energy. What is the value is E mean plus H. I'm going to get E13. Now I'm going to get a new depth of flow, all right, which is Y1 would be greater than my Y0. Okay, if you look at this diagram here, right, and my Y3 is actually less than YC. Of course, definitely lah, because it's in supercritical state, right? So when you draw this, you kind of can, guesstimate your depth of flow already. So therefore, how are we going to get Y1 and Y3? Now, in this case, you really need to solve, this kind of expression. You need to get both answer already, because for one value of specific energy, you need to find y1 and y3 prime. So this would be y1 prime and this would be y3 prime. Okay, so therefore we can actually find E13, which is E mean plus H. So E1 prime, E13 prime is 1.875 meter. If of course is greater than E naught lah. Your E naught earlier is 1.72. All right, this is 1.875. Okay, so therefore, this is the standard specific energy for equation, right? So I want to find E13 prime, E13. Okay, I have a prime lah, it doesn't matter. Okay, now I'm going to substitute all the known values. Okay, remember earlier, right, we have calculated this to be this one, 0.3069. So I'm going to use it. Provided, remember, only in this case, when Q is remain the same, doesn't change. But when, you know, this is from top view. Top view, this is B. That means you are looking from the top view. Sorry, when you are looking from the top, this is the width of a channel. However, if you know the cases when the width decreases, all right, to let's say B2, your Q is not the same here. Your Q2 is not the same as Q0 here. Remember that. This Q2 will be greater lah than Q0. You have to remember that. Okay. So therefore, in this case, this is what we are going to learn next topic. Don't worry about this. I'm just trying to remind you. In this case, we are still using the same Q. So substitute the, you know, discharge over unit width and gravitational acceleration. Solving it, you are going to get 0.3069. Okay, now this is where you need to find Y1 prime and also Y3 prime. Remember, your Y1 should be in subcritical state and your Y3 is in supercritical state. Can you help me solve this? This guy here? Anyone else than Mafira who knows how to solve this equation using calculator to get both answer? Anyone? Ada tak sesiapa selain daripada Mafira?
Saya,
Saya tu siapa je?
Fatima.
Fatima. Fatima ada video tak yang boleh tunjukkan macam mana Fatima tekan calculator? Fatima?
Saya tak ada video tapi saya tekan sendiri.
Ya. Boleh tunjuk. Maksud saya guna you punya webcam. Tunjukkan tak macam mana you tekan calculator?
Sekejap
Okay. Jadi saya stop presenting dulu Alright. So Fatima will show us how I actually rewrite this expression. Saya tulis mula persamaan ni. Apa yang saya buat ialah setiap term ni saya darab dengan that means sebelah kiri dan sebelah kanan saya darab dengan Y13 kuasa 2 lah. Saya nak hapuskan denominator pembawah ni. Jadi saya darabkan sebelah kiri dan sebelah kanan dengan y squared lah. Jadi bila darabkan dengan y squared, saya dapat y cubic power y kuasa 3. Ini dah hilang lah, saya dah hapus. Ini akan dapat darab dengan y kuasa 2. Jadi saya susun balik. Jadi y kuasa 3 tolak 1.875, y kuasa 2 tambah 0.3069. Rasanya Fatimah kena guna persamaan ni untuk selesaikan lah. Betul Fatimah?
Doktor.
Yes?
Betul.
Yes?
Nanti
Okay,
dapat
Fatimah? Ya, Aizat.
nanti dapat 0.466 and 1.77.
Kejap betul. Aizat pun dapat
Tapi saya tak pakai EQN tu.
Oh, you pakai
Saya
guna apa?
yang shift soft tu.
Okay, tak apa. Janji ini macam yang kita buat
dia ada trick.
sebelum ni kan? Yang group 1 pernah explain tu pun boleh. Tak apa. Sama saja. Okay, Fatimah nak tunjukkan? Taiba pun dah dapat. It's actually almost the same as the one that you have done before.
Saya main tukar simbol doktor. Tu dapat dua-dua tu.
Tukar simbol
Awal-awal buat tambah yang original y plus tu semua. So dapat 0.466. Lepas tu saya tukar y tolak. Lepas tu saya kira balik. Lepas tu saya ubah balik jadi tambah. Saya dapat 1.77.
Okay, faham.
Gitu. Tak tahu
Okay.
kenapa.
Tapi you kena guna 2 kali lah
Gitu lah.
Tak apa, kita tengok macam mana Fatimah solve. Nanti kalau next week kita boleh tengok siapa? Mafira pula Okay.
Betul.
Alright. So Fatimah boleh pin ke Fatimah punya video? Kalau video Fatimah kecil. Dia terus
Sekejap. Susah lah nak buka kamera.
Okay. Okay, thank you. I can see your calculator. Everyone, you can pin Fatimah screen to get a bigger look at screen. Okay. Right. Go ahead, Fatimah.
Okay, first tekan yang CL yang mode ni 3 kali.
Clear okay.
Tekan 3 kali sampai nampak EQN tu.
Equation, okay.
Lepas tu tekan 1. Lepas tu nanti dia keluar ni. So kita tekan tepi ni. Nanti dia keluar degree.
Okay.
So degree tertinggi dia kan dekat equation kita tadi 3.
Okay, kuasa 3, okay.
Mana tadi sekejap hilang dah.
Tak apa, pelan-pelan. Okay, nampak dah. Okay.
So tekan ambil degree 3 tu. Tekan 3. Lepas tu yang A ni dia akan keluar A, B, C, D tau.
Perkali
So,
kan kepada kita punya parameter kan? Perkali.
Betul. So dekat A tu ambil yang kuasa paling tinggi dia, yang Y3 tu. So perkali dia 1.
Okay, jadi kena tekan 1
Lepas tu yang nombor 2 pula, yang B tu perkali dia negatif 1.875.
Okay.
Lepas tu yang C tu, kan tadi dah dia kuasa 3 lepas tu kuasa 2. Yang Y kuasa 1 tak ada. So kita letak je kosong.
Okay, betul.
Tekan equal. Lepas tu D tu tekan yang tak ada perkali.
Iaitu 0.3069. Okay.
So 0.3069. Lepas tu tekan equal.
Okay, ini jawapan pertama.
Lepas tu yang jawapan ni tak payah ambil sebab dia negatif. So dia tak valid. Yang ni jawapan kedua.
Jadi sebenarnya you dapat 3 jawapan. Jadi
Ah.
maknanya you ambil yang positif. You are right, betul. Sebab ukur dalam aliran tak mungkin negatif. Okay, mesti positif. Betul-betul.
Okay.
Okay, terima kasih Fatimah.
Sama.
Okay, yang lain semua dapat tak? Boleh nanti.
Dapat.
Yes, thank you. Thank you
Dapat.
Fatimah. You have helped a lot of friends. Okay. Alright. So therefore, okay, I'm going to unpin her. So therefore, jawapannya ialah, so I'm going to share.
Ya?
Ya, saya.
Cara saya sama je dengan Fatimah tu. Sama
Okay.
je
So
calculator tu.
next week you tak nak present dah
Sama
Okay.
je.
Sama Alright. Thank you Mafira. Thanks. It's good to know most of you can actually answer this question. So let's go back. All right. So therefore, you are going to get y equals to 1.778 meter, and also another answer would be 0.4669 meter. Mungkin Aizat boleh consider kot cara ni kan, sebab tak payah tekan 2 kali kan? Ya? Yeah?
Betul.
Alright. So
Saya
jadi
punya cabar sikit.
mencabar sikit. Okay. Jadi kalau saya tengok kat sini rajah yang kita dah lukis tadi. Rajah ni kan? Okay lah, tak apa. Jadi tadi saya tanya, bukan rajah ni tak? Okay, this one. Okay. Now just now I ask you kan, saya kata kalau tengok di rajah ini ataupun dekat diagram ni lah kan, Y1 mestilah dalam keadaan, sebab dia kes 3. Bila kes 3, alright, Y1 mestilah dalam keadaan subcritical, Y3 mestilah dalam keadaan supercritical. Jadi kalau kita tengok di sini, okay, definitely kalau tengok di sini kita punya Y1 ialah 1.778. Sebab kalau tengok dia pun lebih daripada Y0 kan, which is 1.6 meter. So this is our Y1 lah. And then our Y3 would be automatically 0.4669 lah meter. So therefore, we have already solved this lah, because we also have, earlier stated that Y2 equals to YC, right? So therefore, we kind of solved this already. Now, for next class, alright, okay. For next class, I actually want, okay. I want help from you guys, okay, to solve activity 3.12. Is Upcory there? Upcory ada tak?
Ada doktor.
Upcory. Tugas Upcory ialah tunjukkan macam mana kita selesaikan bahagian pertama. Boleh?
Boleh.
Okay. Tavanesh?
Yes, doktor.
Your part is to solve B,
Okay.
Alright. And then Chiyong. Are you there, Chiyong?
Yes.
Alright. So help me solve the third part. Please bear in mind, I think everyone would be subjected to helping us solve all the question. So be alert. Saya memang dah tanda siapa yang saya panggil tu, saya dah tanda dalam list. Yang tak belum panggil lagi tu kena bersedia lah. Kena pastikan ada dalam kelas setiap masa. Alright. So therefore, kalau saya akan share lagi lah YouTube video yang saya pernah share macam mana nak selesaikan contohnya kalau satu specific energy kita akan dapat 2 alternate depths lah, guna calculator lah. Jadi ada soalan lagi tak setakat ni? Do you guys have any question? Kalau tak ada, kita jumpa next Sunday Boleh?
Alright.
Okay. Alright, take care.
The attendance.
Oh,
Thank you,
attendance.
Doctor.
Okay, thank you.
Thank you, Doktor.
Thank you.
Thank you,
Terima
Doktor.
kasih, Doktor.
Okay. Okay.
Thank you, Doktor.
Thank you,
Alright, thank
doktor.
you. Great
Terima kasih,
session, okay?
Doktor.
Alright. Thank you all.
Thank you, Doktor.
Thank you, Doctor.
Thank you. Thank you.
Thank you, Doktor.
Alright, thank you.
Doktor,
Ya, saya. Aizat.
boleh tunjuk balik tak kenapa yang B tadi tu kes 2?
Ya.
Boleh?
So,
Sekejap.
Sebab saya tak
Kenapa
faham.
B? Oh, boleh. Saya boleh
Ah.
explain balik. Okay,
Thank you,
saya.
doktor.
Okay, boleh. Kejap kita share. Window. Okay, nampak kan? Aktiviti 3.11 kan, Aizat?
Nampak.
Okay. Tengok soalan pertama dikata apakah ketinggian minimum untuk mengawal aliran kan dalam saluran, betul? Jadi soalan dia kita cari H-min kan, betul? Dia memang nak kita cari H-min. Jadi bila bahagian B dikata dapatkan ukur dalam aliran di hulu, hilir dan juga di atas empang dasar untuk A.
Oh.
A ialah
untuk
V
A.
H sama dengan H min, betul tak? Sebab tu kes 2.
Oh, I see.
Alright.
Okay. Tak perasan in A tadi tu.
Okay.
Alright. Thank you.
Alright. Okay, siapa lagi ada soalan? Alright, thank you, Jasmine.
Thank you, Doktor. Doktor, sorry saya tak boleh cakap sangat, lidah saya ulcer.
Alah, kesiannya. Okay,
Itu yang
like my
saya
mom
kata.
also. Okay, take care.
Sorry tau.
Tak apa, no worry.
Okay, thank you, Doktor.
Alright, thank you.
Thank you, Doktor.
Thank
you,
you,
Doktor.
Sharika. Alright, thank
Thank you,
you.
Doktor.
Siang, okay.
Thank you, doktor.
Thank you, Doctor.
Okay, alright.
Thank you, Doctor.
Alright, Fahmi.